we are taking, and last will be 1 upon n into log of 1 plus n upon n. This is n upon n here. Why? Because since log m whole over n is equal to n log m. This is the formula of log for products from and power form. Power comes before log. N log m. Similarly, log of this 1 plus n upon n whole power n. 1 upon n is 1 upon n log. This 1 upon n. This 1 upon n log 1 plus n upon n. This 1.3 log 1 plus 3 upon n. 1.2 log 1 plus 2 upon n. Now, what is the n? Rth term here. Or this implies that what is it? For the limit, we have to substitute here. Limit n tends to infinity is whole. We have taken in the limits. Okay, so limit this whole. This will be converted into, now Rth term is limit n tends to infinity sigma sign r is equal to 1 to n. Okay, this is nothing but 1 upon n, 1 upon 1.2, 1 upon this 1.1. Can be first is 1 upon r. Okay, into log of 1 plus r upon n. Right one step. Where r is equal to 1 to n. This r is equal to 1 to n. 1 upon r log, because this 1.2, 1.3, 1 upon n, that is 1 upon r first before log. And log 1 plus r upon 1, 2, 3, 4. This is r upon. Now it can be written further. Let me write it further as limit n tends to infinity. Sigma sign r is equal to 1 to n. It can be multiplied and divided by r. It is 1 upon n. We can write it as 1 upon n into n upon r. We change into log of 1 plus r upon n. With this n upon r can be written as 1 upon r upon n. Let me further write it down. This is limit n tends to infinity. Okay, sigma sign r is equal to 1 to n. This is 1 upon n, 1 upon r upon n into log of 1 plus r upon n. Now it can be converted into definite integral form as we were doing in case of summation of series. Let me convert this into log p is equal to, we are finding out log we have taken log p in the left hand side was log p. Log p is equal to limit n, let me first write limit n tends to infinity sigma sign r is equal to 1 to n. It is 1 upon n into 1 upon r upon n into log of 1 plus r upon n. It can be converted into definite integral as 0 to 1 limits. 1 upon n is dx. We will take this is 1 upon x. 1 upon r upon n is 1 upon x into log of 1 plus x into dx. Okay. Now this is the limit of the given function is converted to definite integral. Now it can be integrated. Now let me write what is the log 1 plus x we know about. Open the series. It will be 0 to 1 upon x as it is. Now log 1 plus x is nothing but x minus x square upon 2. That's x cube upon 3. Sorry. Minus x4 upon 4 plus and so on up to infinity. Okay, to infinity. This is the series ds. Now divide by x first. We will obtain 0 to 1. First is 1 minus 1 x upon 2 will be x upon 2 plus x square upon 3. 1 x is eliminated. X cube upon 3, 4 plus and so on up to infinity into ds. Now integrating each term and then putting the limits. So what do we get here? Now after integrating, This is 1 is x here minus x square upon 2 into 2, 2 square. For 2 is already there. X is integrated as x square upon 2, 2 square. Plus it will be x cube upon 3 square, 3 into 3. Minus x 4 upon 4 square. Plus and so on to infinity. Okay. Now putting the limit 0 to 1. What the series we obtain here? This series will be 1 minus 1 square upon 2 square. This is 1 upon 2 square. It can be written as 1 upon 1 square, 1 upon 2 square, plus 1 upon 3 square, minus 1 upon 4 square, etc. This is nothing but pi square upon 4. Pi square upon 12. The series we know about. There are certain series we have given these formulae in the previous one of the lectures. In that lecture, I gave you this series, value of this series, pi square upon 12, pi square upon 2, pi square upon then 8. Okay, then pi square upon 6 was there. If it is 1 upon 1 square plus 1 upon 2 square, 1 upon 3 square, 1 upon 4, that was pi square upon 6. Okay, and then there was odd numbers, odd squares, 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, etc. It was equal to pi square upon 8. Okay, and then there was even numbers, 1 upon 2 square. Okay, sorry, 1 minus 1 plus 1 upon 2 square plus 1 upon 4 square, 1 upon 6 square, etc. It was equal to pi square upon 48. Okay, so that was the series. So this series is given to us pi square upon 12. This is what log p is equal to. Log p is equal to this pi square upon 12. Finally, we obtain what is the value of p then. When we find out p and eliminate log, then it will come as power of e raised power pi square upon 12. This is the answer. P is equal to. P always log when is removed, it will come as e raised power something. It is e raised power pi square upon 12. This is the answer here. Question number 3 we have done. Now let me take the next question. Question number 4. What is question number 4? Question number 4 is, what is the question number 4? Let me check. Okay. Now question number 4 is, evaluate limit n tends to infinity. It is fourth question. Limit n tends to infinity. Okay. It is within bracket 1 plus 1 upon n4, right, into 1 plus 2 4 upon n4. Okay. Into 1 plus 3 4 upon n4 whole power 1 upon. Okay, this is also coming. I'm sorry, it is 1 upon 2 power, it is 1 upon 3 power also coming, and so on. And sum is 1 plus n4 upon n4 whole power 1 upon n. Okay, this is the series given to us. Limit n tends to infinity, 1 plus 1 upon n4. Okay, in the second bracket it will be 1 plus 2 4 upon n4 whole power 1.2 whole power 1.2 and 1 plus 3 4 upon n4 whole power 1.3. That's it. Now let us consider it first p. In solution, that p is equal to this. That p is equal to limit n tends to infinity within bracket 1 upon 1 plus n4. In the second bracket it is 1 plus 2 4 upon n4 whole power 1 upon 2 into 1 plus 3 4 upon n4 whole power 1 upon 3 and so on. This is 1 plus n4 upon n4 whole power 1 upon n. Okay. Now let us take log on both sides. Taking log on both sides, we get log p on the left hand side is equal to limit n tends to infinity. This as it is. Log of this first is log of 1 plus 1 upon n4 plus 1 upon 2 log of 1 plus 2 4 upon n4 okay, plus 1 upon 3 log of 1 plus 3 4 upon n4 plus let me write here 1 upon n log of 1 plus n4 upon n4. Okay, this is question number. This is 3 nth term. Now let me write what is the nth rth term. Limit n tends to infinity. Sigma sine r is equal to 1 to n. It is nothing but 1 upon r here because 1 upon 2, 1 upon 3, 1 upon 1, etc. is coming. So first is 1 upon r into log of, within bracket it is 1 plus r 4 upon n4. Okay, r 4 upon n4 it is. Where r is equal to 1 to n. This 1 upon r because 1 upon 2, 1 upon 3, 1 upon n it is coming, then 1, 1, 4, 2, 4, 3, 4, and 4, so it is R4. Okay, now let me further write it down as limit n tends to infinity. Limit sigma sign here. This is limit n tends to infinity. Sigma sign r is equal to 1 to n. This is, if I multiply by n or divide by n, it is n upon r into 1 upon n log of 1 plus r upon n whole 4. We can write it as in bracket. Okay, it can be written as 1 upon r upon n. Further, it is limit n tends to infinity. Sigma sign r equal to 1 to n. It is 1 upon n, 1 upon r upon n log of 1 plus r upon n whole power 4. Whole power 4. Now it can be converted to definite integral. So what is the final value? So log p is equal to, therefore log p, in this case, this, let me write here, it is limit n tends to infinity sigma sign r is equal to 1 to n, 1 upon n, 1 upon r upon n log of 1 plus r upon n whole power 4. Okay, now it can be converted into definite integral. Convert this into definite integral. The definite integral of this will be sine of integration 0 to 1. We write it as sine of summation as sine of integration. Limit 0 to 1 because that r upon n. When r is equal to 1 and n tends to infinity, it is 0. When r equal to n, n upon n is 1. So upper limit is 1. Okay, so this is 1 upon x. 1 upon r upon n is 1 upon x log of 1 plus, this is x4 into ds. Now we can write the series again, log 1 plus 1 x4, 1 plus x4. If I write the series of this 0 to 1, 1 upon x, the series of this will be x4 minus x8, x4 whole square upon 2 plus x8 3 24. Because x cube upon 3, that means, but 4 is there, so it is x square 1 plus 4 3 are 12 upon 3 minus sign x4 into 4 means x16 upon 4 plus n4 minus, this is x minus x square upon 2, x cube upon 3, x4 upon 4, but it's 4 already there, multiply by 4. This is up to infinity into dx. Now if I divide by x, what should we get? It will be 0 to 1 limits. It is nothing but x cube minus x7 upon 2 plus x11 upon 3 minus x15 upon 4 plus and so on up to infinity, and this is dx. Now integrate each term. Integration of each term will be, therefore log p is equal to, now first integrated x cube means x4 upon 4 minus it is x8 upon 16, x8 upon 16 here, plus x12 upon 12 into 3 36 is 36 minus x16 upon 16 for the 64 and so on, 0 to 1 limits. If I put here limits 1 at 0 to 0, it is 1.4 minus 1.16 plus 1.36 minus 1.64 and so on. So this is what? This is nothing but, let me write, it is 1.2 square minus 1.4 square plus 1.6 square minus 1.8 square and so on. Now this is even numbers squares. Now this is equal to pi square upon 48. Even pi square upon, it is 48, yeah 48. Pi square upon 48. Because if it is odd numbers, 1.1, 1.3 square, 1.5 square, etc., then it will be pi square upon 8. This is pi square upon 48. Therefore, p is equal to e raised to power pi square upon 48. This is the answer. Value of p we have to calculate. What is p here? P is equal to e raised to power pi square upon 48. This is the answer. Question number 4th we have done. We talk about the next question. Question number 5th. Now question number 5th is, let me check it. Now question number 5th. Before that, let me clean it. Okay, question number 5th is of what kind? Let me check that. Okay, so question number 5th is evaluate limit n tends to infinity. This is limit n tends to infinity within bracket. Okay, it is n plus 1, n plus 2, n plus 3, and so on up to n plus n. Okay, divided by n upon n whole power 1 upon n. Okay, this is question number 5th. N tends to infinity, n plus 1, n plus 2, n plus 3, and so on up to n plus n, 1 upon n whole power. Taking log, so first consider it as p. So solution, for the solution of this, let p is equal to this whole limit n tends to infinity, it is n plus 1, n plus 2, n plus 3, and so on, n plus n, be divided by n whole power n over 1 upon n. It is multiplication of these terms here. If I separate them, let me separate them. Limit n tends to infinity. The first is n plus 1 upon n, because n times n it is. Okay, so n times n, that means n can be multiplied n times. I can write it as n plus 1 upon n. First is, let me write like this. Second is n plus 2 upon n plus 3 upon n, and so on till n plus n upon n whole power 1 upon n. So what do we get here? It is further written as limit n tends to infinity. First is 1 plus 1 upon n. Second is 1 plus 2 upon n. 1 plus 3 upon n. Sorry, 3 upon n. Third is, sorry, and nth term is 1 plus n upon n. In that way we can write it. Now taking log on both sides. Taking log on both sides. Taking log on both sides. On both sides. We get here. What do we get here? This is log b is equal to limit n tends to infinity. Okay, first is 1 upon n will come before. It is, let me write clearly. First is 1 upon n within bracket. It is log 1 plus 1 upon n plus log 1 plus 2 upon n plus log 1 plus 3 upon n plus and so on plus log 1 plus n upon n. Finished. Okay, now rth term of the series. Now rth term of the series will be, let me write here. What do we get here? Log of p is equal to limit n tends to infinity, sigma sine r is equal to 1 to n, 1 upon n within bracket. It is log of, let me write curly bracket, log of 1 plus r upon n. Why it is so? Because we get here 1 plus 1 upon n, log 1 plus 2 upon n, then log 1 plus 3 upon n, etc. It is 1, 2, 3. It is r here we have taken, where r is equal to 1 to n. It is the rth term of the series. Now converting this into, okay, definite integral, it will be 0 to 1 limits. 1 upon n is dx, this is log 1 plus x here into dx. Now integrating it by parts, well, only log 1 plus x there. Integrating it by parts, okay, we could integrate it into. So what is integration? Integrating it by parts. Integrating it by parts. Taking log 1 plus x as first function. As first function. So we get, what do we get here? Log of p on the left hand side is equal to, it is nothing but log 1 plus x of integration of 1 as x, limits 0 to 1, minus sign. Integration of log 1 plus x is 1 upon 1 plus x. Again, sorry, differentiation of log 1 plus x is 1 upon 1 plus x. Now into integration of 1, which is x into dx. Okay, now x upon 1 plus x we have obtained. So let me write here. So what do we get? Log p on the left hand side is equal to log 1 plus x. If I substitute 1 here, that it will be log 1 plus 1 is log 2, 1. It is log 2 only, minus log 0 because log 1 is 0. So if I substitute x equal to 0, it will be log 1. Log 1 is 0. Minus sign, the sign of integration, so 0 to 1 limits here. It is x upon this. So we can write it as 1 plus x 0 to 1 limits minus 1 upon 1 plus x. No change because it was only x here. If I add 1 and subtract 1, it is going to give us something value. The log 2 minus integration. Let me first write it as 0 to 1. It is dx first one minus plus here 1 upon 1 plus x into dx 0 to 1. Now I have written down this in two terms. Okay, after dividing this into two parts, 1 plus x upon 1 plus x, 1, this is here, and minus 1 plus, and 1 upon 1 plus x. Now it can be integrated, which is log 2 minus this is 1 x here, 0 to 1 limits, plus it is nothing but log 1 plus x. If I put the limits 0 to 1, then we will log 2 again. It is log 2 minus 1 here is, if I substitute upper limit, it is 1 only, then minus plus, but plus 0 log, sorry, this in place of x we will substitute 0, lower limit will make it 0, plus log 2 only, because log 1 is 0 at lower limit 0. It will be log 1, then it is 0. So log 2 plus log 2, it is twice log 2 minus 1, it can be slashed log 2 square, but power comes in 4, this power 2 log 2. Well, we want to convert it into log, which is log e, it is log 4 minus log e, that means it is nothing but log of 4 upon e, that's p is equal to, it is log p is equal to log p equal to, therefore p is equal to, or log cancel out, it is 4 upon e. This is the answer. 4 p is equal to 4 upon e. E is exponential term, exponential series. Okay, so e is just log e 1. In place of 1, we have substituted log e. This is the answer. This, I think, this kind of question we have done previously in the first one. I think it was first one. Same type of answer, but yeah, well, it is converted into the same form. Okay, this is question number 8. Now let me talk about 6th question. Now, question number 6, what does it say? Now question number 6 is, let me check it. Okay, so question 6 is here. It is question number 6. Evaluate limit n tends to infinity. It is question number 6 now. Limit n tends to infinity. Okay, it is tangent of tan of pi upon 2n. It is pi upon 2n into tangent of tan of 2 pi upon 2n into tan of 3 pi upon 2n and so on. And sum is log tan of n pi upon n pi. So 2 pi, 2n. It is 2n in the denominator. Log n pi upon 2n. Whole power 1 upon n. Okay. Now considering this as p, the product, let's this is solution. In solution we get it as let p is equal to this whole product. This is limit n tends to infinity. This is limit n tends to infinity. Okay. Tan of pi upon, it is pi upon twice n into tan of 2 pi upon twice n into tangent of 3 pi upon twice n and so on. And sum is tangent of n pi upon twice n whole power 1 upon n. Now taking log on both sides. Taking log on both sides. Taking log on both sides. So we get, taking log on both sides, we get here, what do we get? It is log p in the left hand side. It is equal to limit n tends to infinity. Okay, first is log of tan phi by 2n plus log of tan, yeah, 2 pi upon, this is log 2 pi upon y sin plus log of tan 3 pi upon y sin, and 3 pi upon y sin. Okay, with 3 pi plus and so on. Nth term is log of tan n pi upon twice n. Okay, now let me write the rth term. Rth term will be of this term at limit n tends to infinity. It is sign of summation r is equal to 1 to n into log of tangent of r pi, because it's 1 pi, 2 pi, 3 pi, it will be r into pi upon y's into n. The whole series we have written in the rth term, r form, where r is equal to 1 to 1. But it can be converted into integration sign as 0 to 1. Sorry, 1 upon n, sorry, I'm sorry. Here it was 1 upon n power. It is 1 upon n also here. Log 1 upon n, which is 1 upon n here. Sorry, this 1 upon n power was here. Log m upon log n raised power n is n log n. So n 1 upon n into log, or one of this part. 1 upon n is dx here. It will be nothing but log of tangent, okay, tangent r upon n is x, which is pi x upon 2. When r upon n is x, we take into dx as r upon n is equal to x. We have taken limit is 0 to 1. It is therefore log of tan r pi means r upon n